warahmatullahi wabarakatuh. My name is Siti Nur Aizira binti Muhammad Rozi, and I will be presenting our project Automatic Rice Cooker Dfma Analysis for subject Design for Manufacture and Assemble Dfma code BNG41003. So there are 7 members in my group: Muhammad Syafirul bin Kotter, Muhammad Syahir bin Samsudin, myself Siti Nur Aizira binti Muhammad Rozi, Sofia binti Zainali, Ubaidullah bin Muhammad Najahan, and Muhammad Izzuddin bin Azhar. So I will begin our presentation with the introduction for this project. So Design for Manufacturing and Assembly, or DFMA, is an engineering approach which focuses on minimizing time-to-time market and overall cost of production by prioritizing both the ease of production for the components and the streamlined assembly of those parts into the finished product, both during the early product lifecycle design stages. Dfma used to be regarded as two different methodologies. Before becoming the unique philosophy it is known as today, Design for Manufacturing (DFM) and Design for Assembly (DFA). In order to maximize the total production time and cost, DFM is concerned with sourcing cost-effective raw materials and seeking to mitigate the complexity of manufacturing process during the product design process. So there are few aspects that are important to consider for DFM. First is planning. Planning is where the consulting the template with the expert of production. It is never better than at the design level to reduce the development cost. Second is the materials. When necessary, use manufacturing compliant materials to determine manufacturing procedure and means, management and materials, and quality control. Third is process. Process is where to decrease the prices grabs the manufacturing process. For instance, instead of manufacturing several parts, 3D printing can make one monolithic part design. Lastly is standards. Standards where you use the parts or elements that are common. This, while enhancing inventory control and time to market, it will reduce the expense of new design. Next is the background of problem. So for our project, the task given is to redesign a product so that the cost and time for the production of the product can be lowered maximally. So the product that we have chosen is the automatic rice cooker from the Panasonic company. The model type is SRGA421, which the manufacturer is the Panasonic Home Appliance in Thailand. With the number of total parts is 19 and the number of screws used is R15. Here is the objectives and scopes for this study. The objective for this study are first to disassemble the rice cooker into singular parts for evaluation. Next is to evaluate the assembly efficiency of the original product by using manual DFA evaluation worksheet. Third is to compare the assembly efficiency between the original and redesigned product in terms of assembly time and assembly cost. So the scope of this study includes the software used for evaluation of the original product, and the redesigned product is only the DFM and DFA software provided by the university. Second is there will be no prototype, as for this study to redesign product is only for theoretical. Lastly, the evaluation process will be using the Boothroyd-Dewhurst evaluation worksheet. So for this project, it is expected to reduce the assembly time and cost for the chosen product by applying the DFMA process, while the redesigned product must also meet the customer's need. This study will be helpful to the manufacturer to consider the design improvement made to rake in company's revenue.
My name is Muhammad Syahir bin Samsudin. I will continue the presentation with literature review. First, design for assembly, DFA. DFA and is an estimated design of product based on quantitative characteristic of product. The evaluation criteria for the approach is material cost, labor and or automatic assembly cost, assembly cycle time. Next is design for manufacturing, DFM. It is a systematic approach that allows designer to predict the cost of manufacturing in the early stage of design process, even when it is known only approximate geometry of the product that is being developed. The evaluation criteria for this approach are raw material selection, process selection, modular design, standard component usage, multi-use part development, separate fastener usage, assembly direction minimization. And next is design for manufacturing and assembly, DFMA. A well-established product design technique used to minimize the cost of production and development by designing product that utilize the simplest of components. The FMA guidelines are as follow: to project for a minor parts number, to develop modular design, to design multifunction component, to design component of easy manufacture, to prevent or to reduce setting components such as screw, rivet, and bolts, to eliminate unnecessary adjust and tolerance, to emphasize the standardization of component, to reduce the product parts number, to facilitate the manipulation and the assembly of the final part, to simplify the product structure, reducing the assembly costs and other factors of this nature. Next is a bit introduction of the rice cooker. The electric rice cooker originated from the military equipment used for cooking rice on a running truck. The principle of the cooker is that dielectric heat is produced by electric current passing between two electrodes set at opposite side of the cooking tank. In the automatic rice cooker, a thermostat located at the bottom of the cooker switch off the heater when the water is completely absorbed and the temperature begin to rise rapidly. This is the figure of main component of conventional electric rice cooker that contain a lid, heating plate, removable rice pot, power cord, warm light, cook light, outer pot, and power switch.
Hi, my name is Sofia binti Zanali and I will be presenting on the methodology of this project. So as for introduction, in this chapter, the flowchart of the project will be shown, and the perspective from this chapter is to see the process of the whole project for the rice cooker and design for manufacturing and assembly, the FMA. So the flowchart of the project here shown below is to show where the project is planned, and it is required to achieve all the objectives stated, and also this will help in estimation and also reduce costs for the product development. So the flowchart here, as you can see, is starting with the project planning and followed by introduction to DFMA, problem identification and project part objectives, methodology, DFA table and redesign new product, and end with the conclusion. I will continue with the explanation on the flowchart. So as for introduction of DFA and product design, it is to define the objective and methodology of DFA requirements and comprehensions. And moving on towards literature review, it related to information on the product, benchmark, and latest product design. And moving forward to the methodology, it is to disassemble the parts from the rice cooker and then also to separate the parts into each category to see how the process and to move towards to use the Boothroyd Dewhurst method analysis that will be evaluate from the each of the part and then design efficiency evaluation and calculation. And last but not least is the redesigning. Redesigning is to define the potential part to be modified, and also alteration of method selected parts by eliminating, merging, redesign, and etc. And last but not least, the second evaluation and result comparison is made to see the advantages and disadvantages of the product we redesign and evaluate.
I will continue the presentation with steps in manual Dfma. The analysis of the rice cooker will be done in 5 steps. Step 1 is product disassemble and part identification. The selected rice cooker will be disassembled into a single component so that each part can be calculated, such as part dimension description. The shape of each part can also be determined from the process. We can also decide roughly which sections are not required, so we can remove and enhance the manufacturing process of the rice cooker. Next step is step number 2, which is evaluation of the assembly method, which is Boothroyd-Dewhurst method. The Boothroyd-Dewhurst manual elevation worksheet can be used to test each part in terms of part handling and part insertion difficulties. 2 digits of codes will be given to assist the assessment process by supplying different consumption of assembly time. Step number 3, which is proposed alteration and description of the component to enhance the manufacturing process of the rice cooker. In this step, identifying possible components for simplification, removing, merging, redesign, and so on after a manual assessment has been carried out. When considering an alteration or modification for the rice cooker, it is important to consider the importance of potential minimum part estimate in order to prevent a functionless part. For this step, we need to ensure that the part that we remove give nothing and the function of the rice cooker will remain the same. So we need to ensure that the part is functionless part, so we can remove it to enhance the manufacturing process of the rice cooker. I will proceed to the step number 4, which is a re-evaluation of modified part using Boothroyd-Dewhurst method. Using the same measurement method, which is Boothroyd-Dewhurst evaluation worksheet, recalculation of and the reassess of the efficiency of the planned modification for the component has taken place. We evaluate and assess the modified parts so that the rice cooker will remain function as usually. Last step is step number 5, which is result comparison between original and modified part. For the last step, we compare the result of the original product, which is the original rice cooker, before we enhance and modify it, and we compare the enhanced and modified rice cooker to the original rice cooker to see the difference and to compare the production time, assembling cost, and assembly efficiency. So that's all from me. I will pass to the next presenter to present next slide. Thank you.
I will continue to the chapter 4, which is for the result and discussion. For the 4.2 is about the product analysis. So we go to the product and detail and specification. So the name of product is automatic rice cooker, CR SRGA421. and manufactured by Panasonic Home Appliance Thailand Corporation. So the specification for this rice cooker is power consumption while cooking is 1400 watt, and for the warming is for about 47.5 watt. The capacity cooking is about between 5 to 28 liter. And this is the rest of the specification of this rice cooker. So we continue to the expert view of the assembled original automatic rice cooker. So this is the view of the rice cooker from the top to the bottom. So we'll continue to the tree structure of the automatic rice cooker. So automatic rice cooker divided by three main part, which is first LID assemble, main body, and switch assemble. As we can see, this is about the part in the main body of the automatic rice cooker. So we continue to the evaluation of the original automatic rice cooker. So this table is we had applied from the syllabus that we have learned, and also to the with the with the equation. And then as we can see, we get the design efficiency is about 30%. This is the design efficiency. So next is about the example of handling code and insertion code calculation. For the example is LID handle. So the manual handle is first A alpha plus beta is equal to 540. The part is easily to grasp and manipulate. The thickness is larger than 2 mm. Therefore, the handling code is 20 and estimate time is 1.5 second. For the manual insertion, this part is considered as part secured immediately. This part and associated tool can easily reach their desired location. Screw tightening immediately after insertion. It is easily to align and position with no torsion resistance. Therefore, the insertion code is 38 and the estimate time is 6 seconds. Hence, the total time is about 7.8 seconds, and the total cost is about RM 3.1 cent, 10 cent. The figure for theoretical minimum part estimation is about 1. So that all from me. We will continue to the next chapter.
So I will be explain about the proposed modification of the rice cooker. Proper modification means we remove some parts that are unsuitable of the rice cooker to improve the design efficiency and increase the performance of the rice cooker. The first part that we remove is the decorative panel. For my suggestion, we can only use a sticker to make a decorative panel without making a specific part for the rice cooker to make the decorative panels. It can reduce the cost on making the rice cooker. The second part is the bottom plate. For the information, the main body of the rice cooker and the bottom plate of the rice cooker is separate. So in my suggestion, we can only add a stand at the main body at the bottom of the main body without making a specific bottom plate of the rice cooker. Secondly, the proposed modification that we remove is seam screw. The rice cooker used two screws, which is the tapping screw and also the seam screw. So in the proposed modification, we can just only one screw, which is the tapping screw. We choose the tapping screw because it's more practical and efficiency compared to the seam screw. The last part that we remove is the nameplate. Same as the decorative panels, we can only just make a sticker to edit our brand and add on the sticker. without making a specific part of the nameplate. This is the exploded view of the assembled redesign of the rice cooker after we remove some part, which is the decorative panels, seam screw, nameplate, and also the bottom plate. This is the diagram of the tree structure for the redesigned rice cooker. As we can see, in the main body, we remove the bottom plate assembles, seam screw, and also the nameplate. In the switch assemble, we remove the decorative panel. This is the table of evaluation after redesign of the rice cooker. At the end of the assemble, we get the total number of assemble is 223.6 and the total cost is 89.44, and we only use 26 parts to produce a rice cooker. So the design efficiency at the end of the development, we get 0.35 or 35% of the design efficiency. This is the comparison of data analysis between the original design and the improved design. The first one is the total assemble times. In the redesigned model, we just get only 223.6 seconds compared to the original design, which is 304.5 seconds. So there is a higher improvement that we can achieve, which is we can get a 26.57%. The second one is the total number of parts. For the model of redesign, we just only use 26 parts compared to the original design, which is used 32 parts. So there is an improvement of the total number of parts, which is 18.75%. The thirdly is the total cost for making the rice cooker. In the original design, the total cost of the original design is 121.8 compared to the redesign model, which is 89.44 ringgit. So there is an improvement that we can get, which is the 26.75%. So for the design efficiency of the original design is the 30% compared to the redesign model, which is 35%. There is an improvement that we can achieve, which is 60.67%. So this is the conclusion, the overall conclusion of the project. Based on the analysis that carried out, it can be concluded that the process of design for assemble is very useful for evaluating current automatic rice cooker design. This approach is also very helpful in maximizing production performance and operating costs for the product that we want to evaluate. However, many changes and related fields within this analysis can be analyzed. This analysis should be pursued further. This analysis is just theoretical measurement and product performance improvement. Therefore, this analysis can be further to running a check using all analytic data to assess the consistency of the improved design. We have learned at the end of the project how to apply the definition for computer technologies. This compasses that concept of philosophy of other engineering practice studies too, especially in the field of mechanical engineering. During this coursework, the variety of engineering applications makes the computer design an important subject to be learned. The strong communication between the group leaders, lecturers, and other students also make it possible for the group to complete the assignment on time. Ultimately, from the task given, we gain the knowledge to use engineering procedures to develop a new product. Therefore, the project's goals have been successfully accomplished. That's all from us. Thank you for listening and hearing our video. Thank you.